because the robot, it's all done, it's working, but there's one style of door that for whatever reason the 3D scanner doesn't want to read it. The depth of the pocket of the door that cannot be scanned is 0.5 millimeter less deep than the ones that are working. So what I was thinking is that the width of the frame is a problem, but it actually might be the depth of the pocket. I want to see if increasing the depth of the pocket will solve my problem.
So how are you increasing the depth?
I'm just adding, I have tape, like some Gorilla tape that's like 0.5 millimeter thick, and I'm putting 3 layers, one on top of the other one. So 1, 2, 3. And that adds more than a millimeter in the thickness of the frame. And then I'm gonna run it through the machine one more time. You see, right now, dummy is 0. And it gives me the thickness of the door, the depth of the pocket, and the overall dimension. That's a 2 1/4 inch shaker. This is a 1 inch shaker. This shaker and this shaker, only the frame is different. 0.130, and this one 0.118120. So it's 0.01 less deep, this pocket of an inch. The problem is one of two things: the width of the frame and the depth of the pocket. So the width of the frame, there's nothing I can do about it because I want to have it 1/2 inch, but the depth of the pocket is something that I could fix at the CNC. But it's going to be much faster just to add some tape and run it through the scanner one more time than to recut a deeper door. So you see, the problem is, even though Z1 should be the thickness of the actual door, which is 19 millimeters, and Z2 would be the depth of the pocket, so it should be 1916. But I'm assuming because the width of the frame is smaller than the parameters that are set in the computer, it goes like, no, this is just one flat door, it doesn't have any frame. But the 3D scanner says actually that there is something here that will interfere with the sander. So should I continue and start the robot, this door is going to go through, and as soon as it hits the sensor that detects when the door goes in the sanding area, the robot is just going to go in the cleaning box. It's not even going to try to sand the door because it said dummy here. Because of the parameters that are set in the computer of the sander, it doesn't understand exactly what the 3D scanner sees. So it goes like, oh, there's something in the way here, but this door is only 16 millimeters thick. Computer, in order to save the tool, the sander, doesn't do anything. It just goes and cleans the tool. This is the X axis, and this is the Y axis. And then the Z is the thickness. Y measures the width of the frame, width-wise. 1 should be the thickness of the frame, then 2 should be the distance from the edge of the door to the inside of the second frame, and 3 should be the overall width of the door. But I'm looking now at the scanned door, and the Y, which is the frame, is at 0. So it means that it doesn't recognize this. This most likely is smaller than the minimum dimension set in the computer. This allows me to sand any type of door that we design. So most likely the software, when it was programmed, nobody thought of doing a door with a frame this thick, this thin. We are. So now we have to change some parameters to make sure that we can use the sanding robot for all the doors that we are manufacturing. And now the conclusion is clear. It's not the thickness of the frame, like I was assuming. It's the width of the frame. This is going to be the top of a vanity that's going to be all covered in micro cement. I need to make a flat top that has just a little bit of a dip in it, like a little valley with the drain at the bottom of that little valley, so that it acts like a sink, basically. So it's gonna be a flat top with a little bit of a curvature. In order to be able to do that little curve in it, I need a 1.5 inch thick material. So what I did, I just cut 3/4 of an inch MDF. I'll glue them together like a sandwich, and then I'll have my 1.5 inch thick material. This is the support for the lead screw of the CNC. Somehow fell on the support and it got caught and it bent it and it broke the actual screw here. When this screw is in one piece, the spring like pushes it open and close so that it goes with the gantry. So now I just fixed it. All fixed, ready to go. Cove that goes inside, and then in the middle there I have the drain. So what I have to do now is I'm gonna cut just the top first to see how it works and if it works on the CNC, because it's gonna be done in the blue lines are each pass of the CNC router. It's gonna go deeper and deeper and deeper, and it's about an inch and a quarter deep, the whatever cove pocket into the sink. And if everything goes okay, then I'm gonna build the body of the vanity actually. So this is gonna be, let's call it the countertop, and the rest is gonna be the body. And then we're gonna have under, it's gonna be open so that they have access to the plumbing, and an LED strip all the way at the back. So it's gonna be lit from underneath, wall to wall, with a dip in the top.